graph the following exponential growth functions, label key points, list transformations, write the equations of the asymptotes, and describe the domain and range.
Okay.
And the first equation is y equals 3 to the x minus 2 minus 1.
Like that?
Yep.
Okay. What's the parent function?
Would it be y to the third, or y equals 3?
3 to the x. In other words, the parent function needs to be an exponential function also.
Okay.
Okay. Notice exponential functions are not algebraic functions. There's a big difference between y equals x cubed and y equals 3 to the x. The variable is in the exponent in the second one. That's what makes it an exponential function and not an algebraic one. So when we look for the parent function, oh boy, my eraser has not been working good. I don't know what's going on with it, but hold on one second. I need to get this erased. Oh, there it goes. Okay. So let's graph the parent function. All exponential functions tend to look pretty much the same. In other words, if I drew that, they all go through this point, 0, 1, because anything to the 0th power is 1. So what I just drew there, if I don't label anything else, you can't really tell whether that's 3 to the x or 13 to the x or 100 to the x, because exponential functions all tend to have similar shapes. But we'll say it's 3 to the x. Okay. Now, there's two things being done in the way of transformations. Let's take the easy one. What's the consequences of the minus 1?
Vertical shift down.
Correct. So this point would go down to 0, 0. What's the consequences of the minus 2?
Will that be horizontal shifts?
Yes.
To the right?
Anything that's inside the function is horizontal. Anything that's outside the function is vertical.
Okay.
And that includes reflections. In other words, if I said y equals minus 3 to the x, that negative sign is outside the function. That makes it a vertical reflection, or a reflection over the x-axis. But if I said y equal 3 to the minus x, that minus sign is inside the function. That makes it a horizontal reflection, or over the y-axis. So a good way to remember reflections or transformations is there's 3 verticals and 3 horizontals. All the verticals come outside the function. All the horizontals come inside the function.
Okay.
Okay. So I got 2 things that I have to do. I only have 1 point on this curve. I do know that the parent function has a horizontal asymptote of y equals 0.
Okay.
But we're going to take this point and we're going to shift it 2 units which way?
To the right.
And then 1 down. So if I shift 2 to the right, it becomes 2, 1. And if I shift 1 down, it becomes 2, 0. So this point right here is moved to there. More importantly, what happens to my horizontal asymptote?
Will that be shifted down too?
Down 1.
Okay.
Because it's a vertical move. In other words,
Okay.
it's only being shifted down 1.
Wait, so does every like function, does it always pass through 0, 1?
Yes. Notice that y equals 13 to the x would go through 0, comma 1.
Okay.
Because any number to the 0th power is 1.
Right.
So no matter what the base is of your exponential function, it's going to have this similar shape and go through that point. So that's a
Okay.
key point. And that's the point. Once we've moved our horizontal asymptote, now I can draw, I'm not changing the shape of the curve at all. Neither of these transformations change the shape. In other words, horizontal shifts and vertical shifts do not change the shape. So the shape is going to stay the same, and there's the graph. Now, the only other point that it might be nice to know is that point there. What's that point there going to be?
Um, I don't know.
Well, that's the
Would
new
it be -1?
Y-intercept, right?
Oh, right. Okay. But that can't touch -1, right? Because it's like when
Correct,
you,
correct.
okay.
But it's between 0 and 1, or -1. We can clearly see that. Well,
Right.
the y-intercept means x is 0. So plug in x of 0 here, and what do you get?
Um,
You get 1 over 3 squared minus 1.
okay.
That's 1/9 minus 1 equals minus 8/9. So that's what that point is
Okay.
0, comma, minus 8/9. Now, I think we've answered everything but the range. Well, we didn't do domain and range yet. We did the new asymptote. There's only a horizontal asymptote. And we labeled both intercepts. We know where it goes through the x-axis, and we know where it goes through the y-axis now.
Mhm.
What's the domain?
It's always -infinity through infinity.
Read the domain off the graph. What did
Off the
you say
graph.
it was?
-infinity to infinity.
Yeah, I'm sorry, I didn't hear that the first time.
Oh,
Yeah, you can tell that if I look just at the horizontal movement, it's -infinity to infinity. What about the range?
would that be -8/9 to infinity?
No?
Oh, wait.
-1.
But it doesn't touch negative. Oh, well, you don't include it. Okay.
That's why I have a parenthesis, not a bracket.
Okay.
It does approach -1. In other words, the end behavior, if I extend this all the way to the left, it gets closer and closer to that horizontal asymptote. So
Okay.
that's the proper way to show that range, is -1 to infinity with parentheses. Infinity always has parentheses.
Okay.
Numbers don't always. Sometimes they have a bracket. In other words, if I had a graph that was like this, or say that's at 1, well, now the range on this thing is bracket 1 to infinity,
Okay.
this graph here, because it would be able to be 1.
Okay.
All right. What else do you got?
Let's see. Oh, okay. This one's a little different. So it's negative or y equals -4 times 2 to the x minus 1 minus 2.
Okay, we got a lot going on here. We got a negative sign. What's the consequence of that? Let's just
Or
talk.
reflect
Reflection over what?
the x-axis.
And the consequence of the 4?
That'll be a vertical stretch.
Right. It's outside the function, so it's vertical. It's greater
Okay.
than 1, so it's a stretch. What's the consequence of the minus 1?
A horizontal shift to the right one.
And the consequences of the minus 2.
Vertical shift down too.
Okay. So let's draw the parent function, which is 2 to the x. Going through that point again. That horizontal asymptote. The first thing we ought to do, well, the first thing you always want to do is the reflections. Okay, so let's do these one at a time. I'll do them in different colors.
Okay, so our teacher told us to use like a table and then like add the transformations to them to plot the points.
Okay, I think that's what I'm going to do. Don't know that I need a table.
Well,
Maybe.
she took like X and then Y and then multiply like it was weird. I like the way you're doing it better than
Yeah, I think this will be, I think she's doing the same thing, but I'm not positive. But if we take these one at a time, okay, the first one I'm going to do is the negative sign. Okay? So
Okay.
this function is y equals negative 2 to the x, going through the point 0, comma 1, 0, comma negative 1. That's the only reflection. So now I can do everything else in whatever order I want. Okay? The minus 2 shifts my horizontal asymptote down by 2 units. So if I do it next, let me do that in green. There's my new horizontal asymptote. And the graph for that is going to look like that. And this point is what?
Um, would that be? Oh, is that the intercept that I have to solve?
Uh-huh. Well,
So,
we need a point. Our key point in the original graph is that key point right there. So
okay.
we want to move that point around. And all I've done is reflect it and drop it down 2. So this has got to be 0, comma, minus 2. Excuse me.
But
It's not minus 2. It's, let's see. The first gave us a point of 0, minus 1 on the red curve.
right.
And that's being dropped 2 units down, so it's now 0, minus 3
Okay.
on the green. And the last thing we have to do is move it 1 unit. Oh, no, not the last thing. The other thing we're going to do is move it 1 unit to the right. I'll do that in blue. So this point right there becomes 1, comma, minus 3. And the thing has to go through that. So that will look something like that. And then lastly, I got to stretch it by a factor of 4. And a vertical stretch means that a point that was at 1, comma, minus 3 is now going to be at 1, comma, minus 12. See why?
Multiply it.
Uh,
So
yeah,
you multiply. Okay.
yeah, let me do this one in red also, but it still has the same horizontal asymptote.
Okay.
But now, instead of going through this point of 1 comma minus 3, you multiply the y component, or the y, by 4. So it now goes through 1 comma minus 12, like that. And that point right there is now 1 comma minus 12. The horizontal, the x-coordinate, doesn't change by that vertical stretch. In other words, vertical transformations only affect the y-coordinate. Horizontal transformations only affect the x-coordinate.
All right.
Okay, so our final curve is that one. And now let's answer everything that we need to answer.
Okay.
There's no x-intercept, first of all.
Okay.
What's the y-intercept going to be? What is this point right here going to be?
-3.
Well, let's see, what do we got? Minus 4 times 1/2, that's 2 to the negative 1, minus 2. So that is minus 2 minus 2 minus 4 is this point right there.
Oh. Okay.
Okay, so that point is 0 comma minus 4. So the y-intercept is minus 4. And you can always get that by your table. I think that's what she's doing, is making a table, letting x equal 0, and that will solve for your y-intercept. And that's the only real point. We do have this other point here, 1 comma minus 12, that's on the graph, and that certainly helps in graphing it. But I've found the horizontal asymptote, I've found the y-intercept, and I found another point on the curve.
Okay.
So,
Wait, I have a question.
sure.
So for the range, since the lowest point is -4, do I include that and so like put a bracket around it?
Now the range is going to be from your horizontal asymptote to negative infinity,
Oh.
or
Okay.
negative infinity, comma, -2.
Oh.
In other words, this red graph here, that's the one I'm pointing at with my cursor, it never reaches -2, but it approaches it.
Okay.
Just like all exponential functions. You'll always have parentheses, never brackets. And that's the range. And you always go, when you're dealing in range, you go from bottom to top. Not, in other words, you wouldn't want to say -2 to negative infinity.
Okay.
And that answer everything you needed answered on that question?
Yes.
Domain is all reals.
Yeah. So that's just -infinity to infinity.
And there was no x-intercept. And
Okay.
another way to see if there's an x-intercept, I mean, we can see it graphically that it never reaches the x-axis.
Right.
Also, if there were an x-intercept, there would have to be a solution to that equation. In other words, I would set y equal to 0. That's where y is when you're on the x-axis.
Okay.
And I wouldn't have a solution for that. There's no way that y can be 0. There is no value of x where y is ever 0. Here, let me write it over here. So I'd move the 2 to the other side. So now I have 2 equals -4 times 2 to the x minus 1 divide both sides by minus 4, and I would have minus 1/2 equals 2 to the x minus 1. Well, that is always a positive number.
Okay.
Even if x is negative, that's a positive number. So there's no way a positive base to any kind of exponent can be negative. So that can't be solved. And we see that from the graph that there is no x-intercept.
Okay.
Okay?
All right, and then another question on here says, write the equation for an exponential function with a growth factor of 3 that has the following transformations. Vertical shrink of 1/2, reflection over the x-axis, horizontal shift left 3, and vertical shift up 4.
Okay. So, read the beginning of the problem again.
It says, write the equation for an exponential function with a growth factor of 3 that has the following transformations.
That's all I needed. So that's the growth factor. In other words, that would be the parent function.
Okay.
Okay. And let's do them one at a time. Vertical shrink of 1/2 does what? What would that do?
Like it would, like what it would do to the graph?
No?
What it would do in the...
In other words, first we come up with the parent function.
Okay.
Then we do each one of these one at a time. Well,
Okay.
vertical shrinks happen by multiplying your function in front of the function by 1/2.
Okay.
Notice that this 1/2 is not being taken to the x. 3 is the only thing being taken to the x. So this is a multiplier of your parent function, just like vertical stretches and shrinks all are.
Okay.
Okay, that takes care of that one. Reflection over the x, what's that going to look like?
There's going to be a negative in front of the 1/2.
Horizontal shift left by 3 units.
So that's going to be x plus x plus 3.
Like that. Okay. And finally, a vertical shift up of 4.
So that'll just be plus 4.
There you go. Did they want you to graph it also?
No.
Okay. Just come up with the function.
Yep. I'm trying to find a hard one, the one that I marked down. Oh, okay. This one was tough.
Okay.
Okay, so I have to just graph this one, but it's y equals 2 times 2/3 to the x minus 1 minus 4.
What's the parent function on this one?
Y equals 2 to the x.
2/3 to the x. Well, the
Oh.
growth factor is 2/3. And that matters considerably because when the growth factor is greater than 1, it has the shape of all the other ones we've been drawing.
Yeah.
If the growth factor is between 0 and 1, then it's a decay. In other words, it has this kind of shape. Still always going through that point 0, 1 because everything to the 0th power is 1.
Okay.
Okay? So now the black is the parent function. And let's do each one. There's no reflections, so we can do them in any order that we want. Let's do the 2 first.
Okay.
What's the new point? In other words, if I put a 2 in front of this, where does the 0, 1 go? Where would it move to with a stretch of 2?
Would it? I'm not sure.
It affects only, it's a vertical stretch.
Oh, so it affects only the
Only
X,
the
right?
Y, only the Y.
Oh.
Verticals all affect only the Y. Horizontals all affect only the X.
Oh, that makes sense.
Okay. So this new point that it's going to go to with just, I'm going to do these one at a time, is going to be 0, 2. Right? I'm multiplying the 1 times 2. And
Right.
this curve would be steeper, approaching the same horizontal asymptote, which is always y equals 0 to start with.
Okay.
Okay. Now in green, let's do the next 2 things don't change the shape. In other words, the -1 is merely a horizontal shift, and the -4 is a vertical shift.
Okay.
So I can take this 1 point here and move it to the right by 1 unit and down by 4 units. So where does it go? And move it to the right 1 unit and down by 4 units. What's the new label on that?
So that will be 2.
Oh, hold on. We're moving it 1 unit to the right.
Okay.
So it goes from 0, 2 to 1.
Oh, okay.
And we're moving it 4 units down.
So that'll just. Oh. Wait, where's the. It'll go to -2?
Yeah, because right now it's at 2. In other words, the vertical stretch moved it up from 0, 1 to 0, 2.
Oh,
And
okay.
if I take that point and move it right 1 and down 4, I get this
Okay.
green point.
Okay, I get that.
Okay. And where is my new horizontal asymptote?
Will that be. If it's a decay. Oh, wait.
Well, the old horizontal asymptote of the parent function is the x-axis, right?
Right.
So
So now.
to figure out the horizontal asymptote is all you look for is the vertical shift.
Okay, so
New
it'll be at.
horizontal asymptote is going to be at -4.
Okay.
And that is the equation of a line. So that the equation of that asymptote is y equal -4.
Okay.
All right, so now I'm ready to draw my red curve going through this green dot approaching that horizontal asymptote,
Okay.
like that. So that's my final curve, but I still need a couple of points. I would like to know the x-intercept and the y-intercept. They want both of those, right?
No, I don't have to know those.
Oh, well, okay. I mean, I know this point right here, 1, -2 is on the graph.
Okay.
And when
Oh, well, you
whenever
have to know
you
the
go through
one.
the axes, it's actually a good idea to know these 2 points too, because then I would have 3 points and I would have a very accurate graph.
Okay.
The way I've done it, I've estimated where the graph would be, but let's just see if I've estimated very good. Well, the y-intercept is really easy to figure out.
Right.
That's setting x to 0. So that becomes 2 times 2/3 to the minus 1, which is the same as 3/2,
Okay.
minus 4. Well, that's 3 minus 4, negative 1 is this point right here. The
Okay.
y-intercept is 0, comma, negative 1. And that makes sense, right? I mean, if this point lower than that is 1, comma, minus 2,
Yeah.
then that makes sense. And this one does have an x-intercept, meaning if I set y equal to 0, I should be able to solve it. And you'll notice
Okay.
I will be able to, because now if I go to solve that, I get 4 equals 2 times 2/3 to the x minus 1. Can I solve that? I'm going to divide both sides by 2. So 2 equals 2/3 to the x minus 1. Well, I'd have to take logs to solve this for x. So I'm going to take the log of the left side, and I'm going to take the log of the right side, and then I'm going to take that exponent and move it down in front like that, using the properties of logs. And so now,
I don't think I've used that before.
what's that?
I haven't used the properties of log.
Oh, you haven't? Well, that's
Mm-mm.
probably why she didn't ask you to solve for the x-intercept here. Because
Yeah.
x-intercept is going to be the log of 2 divided by the log of 2/3 all plus
Okay.
1. That's what x is going to equal when y is 0. And that will be a negative number. At least according to my graph, it should be a negative number. But we'd have to get that out of a calculator.
Okay.
In other words, it's not going to be a nice whole number like the others are. Yeah. What else did they ask on this? Just to graph it?
Yep. And then domain and range.
Okay. What's the domain is always all reals for these things. What's the
Yep.
range?
So the range would be um negative 4 to
Uh-huh.
infinity. Okay.
You've had logs or not?
No.
Wow.
We'll probably work on that like
Logs go with exponentials, so you'll have logs next. Because
yeah.
they won't teach you exponentials without teaching you logs. Because
Yeah.
you can't solve exponential equations without logs. In other words, if I told you that 2 to the x equals 7, you can't solve that algebraically. Not even with your calculator you can't solve that.
Yeah.
But if I take the log of both sides, now using the property of logs allows me to bring that x down in front. So now I have the log of 7 equals x log of 2. So x becomes log of 7 divided by log of 2. And
All
that's
right.
a number that solves that equation. But you cannot solve exponential equations using algebra. You have to use logs and then algebra. And
Okay. Yeah.
logs
Probably go
almost
for us.
always taking the log of both sides of the equation, allowing you to get this variable out of the exponent. That's the beauty. Once you take
Okay.
the log of both sides, you can bring that exponent down in front using the properties of logs, which they haven't taught you yet. But you'll be taught that, I'm betting, tomorrow.
Yeah. Probably.
Anna, you good to go?
Yeah. That's really all the questions I had.
Okay, sounds good. I'll talk to you next Tuesday at 8. We're going to do that regular. That works for you?
Yes, I got everything figured out.
Okay, cool. Talk.
Okay, thank
Bye-bye.